Good sound. Alright, so we are doing Kedah Paper 1. Kedah Paper 1. This one is Kedah Paper 1. 2026. So this is all the formulas here. Alright, so we are going to start. If you got any question, please stop me and ask me. So I will do it slowly. Alright, I try to do revision while we are doing the question, right? So first one, right? What is derived quantity? Okay, so we got two kind of physical quantity. One is base and derived, right? One is base quantity. One is derived quantity, right? So what is base quantity? Base quantity only 7. You need to memorize. Only got 7. 7 base quantity, which is if can you help me to list up. Right, that is the 7 best quantity. So length, we are doing revision. Mass, time, electric current. Okay, length, mass, time, electric current. What else? Okay, length, mass, time, length, mass, time, electric current. Still got one more. Number of more. Luminous intensity. Still got one more. What is that? What is one more? Length, mass, time, electric current. You got one more. What is that? I suddenly forget. Let's see. We are doing revision. So, wait. Form 4. Go back to Form 4. What is the best quantities that we have? Temperature. Hiya. Temperature. Okay. So the unit you also need to know. Alright. These 7 best quantity you need to remember also. Right. So what is best quantity? Best quantity is the quantity cannot derive in other term of physical quantity. Right? Quantity that cannot derive in other term of physical quantity. So derived quantity is the combination of one or two or many, right? One or more than one physical quantity by multiplication and division. Right? So for example, area. This one many. Pressure, volume, velocity, all these all can, right? Acceleration. You look at the unit. So this unit will be meter, right? So this unit is meter times meter square. So it is more than one unit, right? Or one unit only, it serves only meter also. Meter only, meter times meter. So multiplication of best quantity, right? That one is called direct quantity. So this one cannot just meter itself, kg itself. second itself, right? Current, it is ampere itself. Temperature, it is Kelvin itself, right? Number of mole is mole itself, right? Luminous intensity is candela, ED, right? So cannot combine with other. So this one is pressure. The unit is kg ms. We normally use Newton, right? Not Newton, PA, Pascal, right? PA. Pressure, it is force over area. Kg ms negative 2 divided by area, m negative m2. So cancel the m, kg m negative 1, s negative 2. The unit very hard to remember, right? You need to derive on your own, okay? So if you don't understand, stop me. So this is physical quantity. So what is derived quantity? Physical quantity has a magnitude. Magnitude only, it is called scalar, right? I don't want to write this here. We'll write here scalar quantity, right? So physical quantity that has both magnitude and direction, this is called vector. So vector quantity. So this one, I don't do it now. I don't go into detail like what I did just now. Because of we are doing this. Next time, next paper, maybe we got this one, then we'll go into detail. So physical quantity which cannot be derived in other term of physical quantity, it is best quantity. So physical quantity is derived from multiplication or division of best quantity or both operation. Yes. Alright, so this one is our answer. Right? So next question. Diagram 1 shows a strip of the ticker tape by moving a trolley. Right? You move the trolley into this way. What type of the motion of the trolley? You want to see what is the type of the motion, you have to see the distance between them. Right? Distance between them. So distance between them, it is constant. So this distance, it is constant. Constant, then we call it as constant velocity, or we call it as uniform velocity. Uniform velocity. But when you do this kind of question, you have to be very, very careful when this is chapter 2. Okay, we do a bit of revision about this linear motion graph. I think it is here. Good. Okay. I am not touching the calculation. So we just go for this kind, right? So now the type of the motion here, it is, you see the distance here, it is same. All right, and this is called constant velocity. So this is same, but the distance very near. So we call this one as slow. Right, this one is fast, constant velocity. This one is slow. Right, now from small become big, the distance here is small become big. So you have to see the direction here, pulling from here, right? So from slow to fast, so we call it as acceleration. From far, this one far means fast, here slow, right? So we call it deceleration. But anyhow, you need to see this arrow. This arrow means pull it from here. So this one is initial velocity. This is final velocity. Right? So this question here, it is the same. So now, but this one, it is pulling from here. So you have to see this one first. Right? This one, This one is same as this one. Same as this one, same as this one, same as this one, right? So it is constant velocity, or we call it as uniform velocity. But anyhow, if you see this one, it is here, far, and then near, and then near, and then near, and then near, and then near. So this one is fast, this one is slow. So you see the direction of the motion, it is from here. So this is initial velocity, this is final velocity. All right, so initial velocity is fast to slow, so we call it deceleration. Okay, you need to know properly. Okay, next. Diagram 2 shows a basketball and the tennis ball being dropped in the vacuum. Alright. So which of the following time graph shows a correct motion of the basketball and the tennis? Right. So this one drop in the vacuum, we call it as free fall. Free falling. Alright. So during free falling, there is no friction. Right. But you cannot write if they ask you what is free fall. Right, you cannot say, oh, no friction, which is wrong. Right, so you have to say the object undergoes free fall when what? Right, the object undergoes free fall when there is no other force acting on the object except gravitational force. All right, when only gravitational force act on the object. Only, right? No other force, only gravitational force. So which of the following velocity time graph shows the correct motion of the basketball and the tennis ball? Right, so when there is no friction, these objects they don't base on the mass, right? They don't see the mass. This one big, this one small, because no friction. So they are going to reach at the same time. So the velocity here and the velocity here will be the same. Mean the acceleration here and acceleration here will be the same. Even, right? Even the mass here, it is a metal ball. This is a feather, right? This one much more lighter, right? They will be the same to reach the ground, right? Time taken will be the same. So which one is the graph? So which one will be the graph? Answer is A, right? So here, see here. So we do a bit of revision. Free falling. So the gravitational acceleration remain constant when the object is falling. The mass will not affect the time taken for the object to drop onto the ground, right? Meaning that if you got a feather, you got a ball bearing, right? In the air, so the ball bearing will go first, will reach first, all right? But if you fall in the vacuum, right? Feather and the ball bearing will reach at the same time, no air resistance. So we call it as free falling. Okay, so the graph will look like this, right? What is the gradient of the graph represent? The gradient of the graph represent acceleration, right? Okay. An object will remain at rest and continue to move with uniform velocity unless it is acted upon by the external force to change its state of motion. What is the physics law explained by the statement above, right? So this is Newton's first law, right? This is Newton's first law. Right? Newton's first law said that an object that is moving, it will continue to move in a straight line, right? Unless there is an external force act on the object, right? Newton's first law, right? Also, Newton's first law, also known as inertial law. Okay, Newton's first law, also known as the inertial law. Right. Object that is moving, it will stay at rest, it will continue to stay at rest. Right. Or when it is moving, it will continue to move. Right. So this is Newton's first law. Right. Newton's second law said that F is equal to ma. Right. So force is directly proportional. Force is directly proportional to change in the momentum. Right. M v minus u over t. Right. Change in the momentum. F is directly proportional to rate of change in momentum. I'm sorry. Rate of change in momentum. Right. This is the Newton's second law. Newton's third law said that an object that is stay at rest, sorry. For every action, there is a reaction. So this is Ft is equal to mv minus mu. Right. So this is Newton's third law. For every action, there will be a reaction at the opposite direction, but same magnitude. Right. Newton law, Newton universal law of gravitation. You know lah. This one I don't want. Right. Okay. So number 5. Right. Stop me if you think I'm too fast, huh? Or you can ask in Mandarin. If you ask in Mandarin, then I will answer you in Mandarin also. Right. So which of the following does not occur when the force is applied onto the object? Right. So what is not occur? So the speed of the object increase, the shape of the object change, the mass of the object decrease, the direction of the object change. So what is not occurring? So answer is D. Right. When there is an object here, right? So you push it, right? It is moving. You push it. You push it. Maybe, right? So the object is moving already. So you push it, so you move faster, right? So you push it here, you squeeze it, so the shape may be changed, right? But you squeeze it, the mass will not change. It is 1 kilo, then 1 kilo, 1 kg, then 1 kg. So yeah, the shape change. It probably will change the shape, but the mass will not change, right? So if it is moving this way, you push it into the other way around. Push it this way, right? So the direction of the motion change. Yes, possible. So the mass will never change, right? Now, what effect does the low gravity have on human? Right, this one. I'm not good into this one. So what effect on the low gravity? Bone fragility decrease, bone density increase, blood pressure decrease, size of the lung decrease. Okay, low gravity. Okay, low gravity. So, I'm not so sure this one. Low gravity mean the bone fragility decrease. Bone density increase. Density is equals to mass equals mass over volume. So the mass will never change, the volume will not change. So density will not change. So this one is wrong. Right? Blood pressure decrease. Size of the lung decrease. I'm not sure whether this one A or C. I'm not sure. Right? I think it is A. I think it should be A. So we go to see the answer. I'm not sure. Question number 6, it is C. I'm not sure this one. Alright. Blood pressure decrease. Why? Right. The answer is C. Blood pressure decrease. So maybe lah. Okay, let me explain. I think. I'm not sure. So now when the gravity it is lesser, so meaning that the particle will move away, people away easily. So it will not like gravity will pull the particle go near to the earth center, right? So now this one, the density very not density, the particle is moving randomly into all the direction because the gravity is less. So it is harder for you to breathe. Harder for you to breathe. So the blood pressure will be lesser, I think. I think. Okay. Okay. Number 7. You see, the pattern of the question asked in SPM is how? How do they ask in SPM? So there is a few questions in chapter 1, chapter 2, chapter 3, chapter 4, chapter 5. So it will not like total all of the question come in one chapter, no. Right? They'll follow. There is 40 questions there. Right? So every chapter you also need to learn. But some of the chapter, if you don't learn, you'll miss like one or two questions that you don't know how to. Okay? So number 7. Right, this is chapter 3. Chapter 3. Diagram 3 shows the planet Mars orbiting the Sun at the average speed of 24.1 km per second. The time taken from P to Q, where is P to Q? P to Q is same as R to S, R to S. Which statement it is correct describing the movement of the planet Mars in the orbiter? Okay. A. The area of the RST, RST, area of the RST is same as PTQ, right? Yeah, right. The area it is the same, right? Area it is the same. The acceleration of P to Q and R to S, it is P to Q and R to S, it is the same. No. The time here, time. So this one is second. What is that called? Need to do revision. Kepler law. Kepler second law. Right? Kepler second law. This is Kepler second law. Kepler law. Okay. First law, we do revision. Kepler first law said that all the planets move in the elliptical orbit with Sun at one focus. Alright? So here it is focus, here it is focus. Right? Second one, law of orbit, law of area. Alright? So a line that connect a planet to the Sun sweep out equal area in equal time. Law of area. Meaning that here it is going fast. When it is near to the Sun, it go fast. So when it's far away from Sun, it is going slow. And then the area here is equal to the area here. Right? Area here is equal to area here, which is in this question. So the area of the here is equal to the area of here. Yes, correct. right? The distance from P to Q is the same to R to S. No, 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 no. Average speed PQ is same as RS. No, 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 no. Okay. So, next one it is one more. Third law. Kepler's third law said that T square is directly proportional to R cube. Orbital period square of the planet is directly proportional to the radius of the orbit in cube. Okay, so you need to know this. You need to memorize this. These three. It is very, very commonly asked in SPM. Question number 8. Diagram 4 shows Malaysian-made satellite Rajaksat. This satellite it is equipped with the high-resolution camera in imaging Earth surface. The satellite was launched on 14 July 29. Which statement it is correct about the characteristic of the satellite? So, let me read one more time. Orbiting in Earth in geo-Earth orbit. So, orbiting in geo-orbit. So, we got two kind of satellite. One is geo satellite, and it is not. One more is non-geo. Right? Geo and non-geo. Geo, it is always same geographical location. I don't want to write. I go to look for that one. So, geostationary and non-geostationary. Yeah. So, geostationary, it is always same geographical location, same direction of the Earth rotate. Period is 24 hours, and then it is going into the special orbit named geostationary Earth orbit. So non-geo, it is terbalik lah, right? So normally in lower or higher orbit, right? Then geostationary Earth orbit, and can be same direction or opposite direction. Orbital period is not 24 hours, and above different geographical location at a different time, right? So example, it is this one, right? Tungsat, Rajaksat. So this one, if you can memorize, then memorize. Cannot memorize, then leave it. Leave it if you cannot. Leave it if cannot. So this is non-geo. Non-geo, Rajaksat, yeah. So this is Rajaksat, Rajaksat, non-geo. So non-geo. Even teacher, I cannot memorize. So never mind, you see. This is, you know, this is geo, right? You write it down, it is geo. Here, orbiter, same as the Earth, geo. Right? Orbiting the Earth to the opposite direction, non-geo. And then the geographical location of Earth's surface keep change. Right? Non-geo. Wait, orbiting the Earth in the opposite direction of the Earth rotation. Non-geo. The orbital period is same as the Earth rotation. Orbital period same as Earth rotation. Geo. Geo. Why it is like that? The geographical location keep change. Same geographical we call geostationary. So this one is non-geo. Orbiting the Earth in the opposite direction. Opposite to the direction of Earth rotation. Non-geo. Same to the Earth, it is geo. Huh? Something wrong, right? This question something wrong. Am I? I guess it is something wrong. Wait, Okay, wait. Ask AI. I don't believe in the answer. Right? Ask AI. Help me to see what is the answer for this question. Thank you. Help me to see what is an unofficial question. Right, answer is D. Answer is D, they said. Right. D is correct because of low orbiting satellite travel around the Earth. It is 14 days. Alright. Geographical location relatively to the Earth surface is constantly changed. Right. C, it is incorrect. Right. This is non-geo. Right. So C, its orbit in the prograde direction rather than the opposite to it, maximizing to launch the velocity provided the Earth by the Earth rotation. I don't get it. Why? But, we see the answer first. We see the answer. This one is number 8. Number 8. Number 8 is D, the answer. Number 8 answer is D. Yeah, D. D. But C also non-geo. Right. C also non-geo. Let me see. Orbiting the Earth in the opposite direction of the Earth rotation. It is not correct. Not to say this one it is correct or wrong, but yeah, if not mistaken, alright. Why? Normally, this is the Earth. Alright. So this is a satellite. If Earth rotate in this way, alright, so normally the satellite will orbit into the same direction. Just Earth, it is 24 hour. The period is 24 hour. So this one is 24 hour. Yeah, it is geostationary. If it is not 24 hour, like for example, the period is 10 hours, it is non-geo. Okay, it is non-geo. But can be go into the opposite direction, very hard. Right, very hard. So it normally we will not go into the opposite direction. So if it go into the opposite direction at the Earth, very rarely, because of why? Just very hard lah. I just need to tell you it is very hard. 很难发生. If not mistaken, we do it before when we are in Form 4. Right? I use AI to ask why. I use AI. AI answer me. Right? Why it is hard to. You also can ask in with by using AI lah. They will answer you. Alright, very hard to go into the opposite direction. Okay, so answer is D. Okay, number 9. Diagram 5 shows a hot water poured into the cup. The water is left until it reaches thermal equilibrium with the surrounding. So thermal equilibrium, this one thermal equilibrium. So what is thermal equilibrium? Thermal equilibrium reaches when net heat flow equal to 0 and temperature, it is the same. Right? Temperature of both objects will be the same. Right? So temperature of water is higher than temperature of A. Right? Net rate of heat transfer is 0. Okay, quite correct. This one is quite correct. Right? We see others. No heat transfer between. Right? There is heat transfer, but the net heat transfer is 0. Okay? Net heat flow is equal to 0. The rate of heat transfer from water is higher. No. So answer is B. Net heat flow is equal to 0. So you have to remember, net heat flow is equal to 0. Right? Next one. Diagram 6 shows the ice cubes melt in the glass. throughout the process, the temperature of the ice in the glass does not change. Why the temperature of the ice does not increase even in the hot surrounding? Right, the temperature no change. Yeah? So because of heat absorbed by the ice to weaken the molecule bond of the ice. Heat absorbed by the ice break the bond of ice. Heat absorbed by the ice to increase the kinetic energy of the ice. Heat absorbed by the ice to decrease the kinetic energy. Which one? Right. So, to weaken the bond or to break the bond. Either one. Right. I'm not sure which one. Right. Yeah. Wait. We go see chapter 4. Right. Latent heat. This one is called latent heat. Okay. When come to here, solid and liquid, so the latent heat is absorbed to weaken the bond between the molecules. Weaken the bonds between the molecule. So here it is latent heat of vaporization. Vaporization is break the bond. Right? The difference is weaken the bond and break the bond. So this one is weaken the bond. Right? So this one is weaken the bond. So weaken the bond. Answer it is A. Okay. So we see the answer number 10. 10 answer is A. Weaken the bond. Okay. Weaken the bond. So you need to memorize. Break the bond is a latent heat of vaporization. So this is fusion. Latent heat of fusion. So this one is latent heat of vaporization. Alright, you need to memorize. This one break the bond. Vaporization from here. Here. Okay. Alright. So diagram 7 shows a capillary tube containing trap A at the temperature 30 degrees Celsius. At the height of the trap column, it is 12 cm. Right? Calculate the final temperature of the trap A column. Okay. So the capillary tube is heated until the trap A increased to 14 cm. Right? From 12 to 14. They never said how much is the atmospheric pressure. V and okay. So this one is we use P1 V1 P1 V1 over P1. P V over P is equals to only objective you can do it this way. This is what I taught you. You can do it this way faster. Right? We do revision. So this is PV over T. This is called Boyle's law. Right? This is called Charles' law. This is called Gay-Lussac law. Boyle's law said what? Boyle's law said P is inversely proportional to V, right? Provided temperature keep constant. Charles' law said that V is directly proportional to absolute temperature, provided P keep constant. And Gay-Lussac law said that pressure is directly proportional to absolute temperature, provided the volume keep constant. So when you calculate, you don't care what law. You just PVT. right? So all the formula you can use, right? All the question you can use, right? Now P here is, so you must see where is the trap A. Trap A is at here, right? Trap A is at here, right? So now this one, it is pressing downward, right? Normally it is 76, huh? So because of this is Mercury, I said 76. 76 plus 5. Why plus 5? 76, it is pressing down, right? Right? For the gravity here, 76 is pressing downward, right? And 5 cm Mercury, it is pressing downward, right? So altogether is 76 plus 5, the pressure, right? And then volume it is 12. Mm. Mm. Temperature is, at first it is 30 degrees Celsius. 30 degrees Celsius, they said, right? 30 degree, yeah. But this one have to change to absolute temperature. So you have to plus 273, right? So now P2, V2 over T2. P2. Now, do they change the pressure? No, it is still said they don't give the pressure. So still 76 plus 5. Volume, I don't know. Wait, volume, I guess I know. The question do say, right, 14. Right, change to 14. Yeah, change to 14. The volume here changed to 14 degrees Celsius, right? So what is the final temperature? You have to plus 273. So actually, this pressure here, you can cancel and cancel, right? This one cancel, this one cancel. You don't need to put in, right? So you want to find this one, right? So this one go up. Take out your calculator. So this one go up. This one whole thing go down. This 75, 76 cancel already, yeah? So I just leave it. This one I cancel it. If not later, you want to press it. So now 14 divided by 12. 14 divided by 12, right? Equal time this one, right? Time, answer, time 30 plus 273, right? Already? And then this one is here. This whole thing is here. I want to minus 273. This whole thing is here. Alright, I do it slowly again. E plus 273, it is equal to 14 here. This one time 30 plus 273. Right? This 12 is here, at here, time it up. So I move it down. So 14 divided by 12 just now. 14 divided by 12 times 30 plus 273. And then this one come to here become minus. Right? Minus 273. E. Oh, never mind. Repress. 14 times 30 plus 273 divided by 12 equal minus 273. Okay, that's the answer. At T.5. So T gonna be at T.5 degrees Celsius. So at T.5 degrees Celsius. Answer is C. Answer is C. You okay with it here? Huh? Alright, number 11. 11, answer is C. So number 12. Which wave it is longitudinal wave? Longitudinal wave can be divided by two types. Right? One is longitudinal, one is transverse. Longitudinal, one example is only sound. Right? Water, radio, light wave, Ultrasonic. Ultrasonic is sound wave. Ultrasound, right? Sound wave, right? So other than longitudinal is transverse wave. Water wave, radio wave, light wave, or transverse wave. Okay. Okay. So diagram 8 shows the two identical tuning forks P and Q are placed side by side. When the tuning forks knock, the resulting vibration has forced the Q to oscillate with maximum amplitude. So this one is called resonant. The keyword of the resonant is forced to oscillate with maximum amplitude. Right. Two keyword natural frequency and maximum amplitude. Remember this. Right, resonant. So damping, what is damping again? Damping, it is decreasing in the amplitude because of loss of energy to surrounding. Right. Okay. Number 14. Diagram 9 shows the water propagate toward a plane reflector in an experiment by using a ripple tank. So, which of the comparison it is correct between the incident wave and reflected wave? So the angle I must be equal to R. Okay, during the reflection, I must be equal to R. Wait, during the reflection, I must be equal to R. Right? Here, I gave you the notes here. Right? Incident and reflected angle must be same. Wavelength, no change. Frequency, no change. Speed, no change. Direction of propagation change only. Okay? So here. So the angle greater, wrong. This one should be the same. The speed of the reflected wave is the same as the incident wave. Yes. Right? Yes. Speed same. Then here. Speed, it is no change. Still same. Okay? The frequency of the wave, it is lower. No. It must be the same. Right? Frequency must be the same. Now the wavelength of the reflected wave, it is less than the wavelength of the incident. No, it must be the same. Alright? Okay, must be the same. Next one. Number 15. Diagram 10 shows the diffraction of water wave occur after pass through the obstacle. Which physical quantity will change after diffraction occur? Right? So the wavelength will change? No. The frequency will never change. Amplitude, amplitude will change a little bit. Right? Speed will no change. Right? Diffraction. So only amplitude will change. Only amplitude change. Diffraction. This is called diffraction. Diffraction. We look at the diffraction. Amplitude decreasing. Right? So when the wave diverge or spread out from a region, so the amplitude will slightly decrease a little bit. Okay, so frequency remain, wavelength remain, speed remain. Right? Wavelength, frequency, speed all remain, just amplitude decrease. Right? Change. Right? Okay. Number 16. Okay. I read and then you do. Maybe we rest for a little while. We'll rest for 5 minutes. No, 5 to 10 minutes. Right? You if you don't want to rest, you can try to do this question. So I'll be right back to do this question later. Right? You try to do this question and see whether you remember or not. The formula, you can look at the top of the question there. Lambda is equals to a x over d. Right? You try to do it. I'll be right back. Alright, see you later. do this question. All right, so let's do it together. Lambda is equal to ax over d. Lambda is equal to ax over d. Okay, what do they want to find? The wavelength, it is 6.5. 6.5 times 10 to the power of negative 7. Is equal to ax over d. A is something very small. Alright, A is very small. Alright, 0.02 milli. Milli is times 10 to the negative 3. X. What is the distance between two consecutive bright fringes? So this is called X. D is something quite big here. It is 3. Okay. This one go up, become time. 6.5 time. Now, I taught you before. These two number, it is the same. These two number, it is the same. So you cannot do any, like just press a number only. Okay. Previously, I taught you. But now you have to press the exponent negative 7 times 3 divided by 0.02 exponent negative 3. Right? The answer is 0.0975. Right? So you press engineering for one time. So this is 9.7. Right? 9.75. This one becomes smaller. This one become bigger. Plus 1. Negative 3 plus 1 negative 2. Negative 2. So answer is D. Right? X is 9.75 times 10 to the negative 2. Unit, it is in meter. Right? Meter. So answer will be D. 16 answer is D. Okay. Okay. Next one. Diagram 12 shows the type of the electromagnetic waves which are RSTU forming a continuous spectrum, so known as the electromagnetic spectrum. So what position represented by visible light? Okay, so you have to memorize, right? So how to memorize? Ringgit, Malaysia is very ultra not good. Alright. Radio, micro, infrared, visible light, ultraviolet, X-ray, gamma ray. Right? Ringgit, Malaysia is very ultra not good. Okay. So they want visible light S. Visible light S. Answer S. Okay. All right. Now, diagram 3 shows the drinking straw placed in a glass of the appearing band at the water surface. What caused the drinking water to appear to be bent? Alright, why it is bent? So reflection. Alright, reflected. Light is reflect. Not reflect, reflected. Okay, reflection of light. So what is the reflection of light? Reflection of light is changing of the speed of light when the light go into the different medium, right? Different optical density medium. Number 19. In a modern communication system such as a high-speed internet, the light is transmitted through an optical fiber which applies total internal reflection. Which condition allow total internal reflection? So there is two conditions. So you need to memorize. First one is incident and incident angle is more than critical angle. First one. And then the light must travel from denser to less dense. Right? Denser to less dense. So we do a bit of revision from here. Total internal reflection. So two things that you need to remember is incident angle more than critical angle, and light travel from denser medium to less dense medium. Okay, so that the total internal reflection can occur. First one, the angle incident is equal to the critical angle. No, greater. Incident angle is greater than the critical angle. Yes, number two. So number two, number two, number two, number two. Left 3 and 4. Now the light propagate from lower optical density to higher. Should be denser. So higher to lower. Right? The light propagate from higher optical density to lower. So answer is 2 and 4. 2 and 4 is D. 19 answer it is D. Okay. A small bulb is placed at the 90 cm from a convex lens with a focal length 30. A sharp image is formed on the screen behind the lens. What is the distance image? Do you want to find V? So this one is 1 over F is equals to 1 over V plus 1 over U. One over F. F is focal length. Focal length is 30. Right. Now, this one you have to be very, very careful. This F. You have to see what kind of lens it is. Convex lens, it is positive. Concave lens. Concave lens, it is negative. Right, negative. So this one, it is positive. Positive, no problem. Right, 1 on F. 1 on V. V is your image distance. So I don't have it. I don't have it. 1 over U. U is object distance. Object distance is 90. 30 or 90? Okay. 90. Yeah, 90. Right? So how to calculate the V is 30 inverse minus 90 inverse. 30 inverse minus 90 inverse equal. Inverse equal. The answer is 45. V is 45 cm. Right? This is distance after. You have to read properly. Determine the image distance from the lens. Yes, correct. Right? If they said determine the image distance from the object, so you have to 45 plus 30. Be careful. So this one is 45. Okay, normally it is, they will ask in this way lah. No problem one. So answer it is C. Answer it is C. Number 20. Answer it is C. In a normal adjustment of the telescope, what is the final image form? I don't remember. Telescope, infinity, should be infinity. At infinity. Right. If I want to draw, it will take a lot of time. So I don't want to spend too long time here. I just show you. This one. Yes. Where? Here. The image form at infinity. So this is telescope. Telescope image form at infinity. Alright. Image form at infinity. So answer 21, it is D. 21 answer is this D. Diagram 14.1, 14.2 shows the image of the car seen through the car side mirror. Okay, which of the following it is correct? Both diagrams are using convex. No, one it is bigger, one it is smaller. Alright. Smaller one it is convex. This one it is bigger one it is not convex. Alright. Both are using convex. I don't think so. Right. The image form in the both diagram is virtual. Virtual is cannot form on the screen one. Yes, correct. Virtual upright. So the image size increase when the object distance is increased. Mean further. If you go further, the image size should be smaller. Alright, this one is out. Number 3 is out. 3 out, 3 out, left 2, 4, and 2, 1. The image in the mirror is formed due to the reflection of light, due to the reflection of reflector FL of light at the mirror surface. So answer should be 1 and 2 then. 1 and 2 answer is A. Answer is A. 22 answer it is A. 22 answer is A. Alright. Next. Okay. Diagram 15 shows a car moving with uniform velocity on a road. Okay. So which one it is? The first it is correct. Uniform velocity mean, right? Uniform velocity mean equilibrium. In up and down and left and right will be the same. So we see R more than W. R more than W mean it will go up. So out. Right? FT is more than FF. FT is more equal than FF. Yes, correct. FT more than FF mean it will accelerate. W, weight is more than the FF is nothing. I don't know what is this. Right? So answer is B, equilibrium. Equilibrium, when you see the car moving with uniform velocity mean equilibrium. Right? Mean left is equal to right, up is equal to down. Okay? 24. Diagram 16 show a force resolve into the perpendicular component, namely horizontal and vertical, Fx and Fy. Set the formula. So, still remember, this one, F, you bring to here, touch, you use cos, right? Here, you don't touch, you use sine, right? So, if you follow my class before, then you know, right? Touch, you use cos. Not touch, use sine, okay? So, now you want to find x, fx. Fx, do you touch or not? You see the theta is here, touch, right? You use cos. F cos theta. F cos theta. F cos theta. Answer is A. Answer is A. Right? 24. Answer is A. Touch, use cos. Not touching, use sine. So, Diagram 17 shows a box with the mass 5 kg rest on the rough inclined plane. So calculate the value of frictional force. Rest means up and down will be the same. So the force here is equal to the force here, right? The force here is equal to here. So what is this force? This force, it is weight. Alright, we label all the force first. Here, this one is called weight, right? mg, right? W, right? It's also mg, right? So this one, it is your theta. Here, theta 35 degrees. So here is 35 degrees. This here is 35 degrees. So this W, you want to pull it into here. Alright. Touch 35 or not. Touch 35 or not. You bring to here. You don't touch, right? You don't touch. You use sign. You use sign. So FR is equals to W sine 35. FR is equals to W sine 35. So how much is W? W is your weight. Weight is mg. M is 5, G is 9.81. 5 times 9.81 times sine 35. Right? Is your answer. 5 times 9.81 times sine 35. Right? That's your answer. 28.1. 28.1. 13. Right? 28.13. The answer will be C. Do you need me to repeat for one more time? If you need, do let me know. Alright? Do let me know. Do let me know. So 25 answer is C. 25 answer is C. Yes, you need lah. This one, quite many of you not really good into this one. Okay, one more time. The force up and down, it is the same. Why? Because raise, the word of raise. Right? Raise means same up and down. Even if they said moving down, uniform velocity, also equilibrium, also up and down will be the same. Right? So the force here is equals to the force here. Right? The force here is FR. FR here. The force here is W, not touching 35. Not touching, we use sign. Alright, we use sign. So you got 28.13. Alright, so 26 is this pressure already. Diagram 18 shows a fish below the surface of the sea. Calculate the actual pressure acting on the fish. Alright, so what is the actual pressure acting on the fish? So the pressure is the atmospheric pressure plus here. Right? So the pressure is equals to PATM, atmospheric pressure, ATM, atmospheric pressure, plus water pressure, right? So I see what is the unit Pascal, plus rho GH. Rho GH, right? So atmospheric pressure is 1 times 10 power 5. 1.00 times 10 power 5. Plus rho, density of the water, 1.03, right? 1.03 times 10 to the power of 3. G is 9.81. H is how deep it is. Right? How deep it is 8. Right? 10 minus 2, it is 8. Right? Here it is 8. Okay. So here 1 exponent 5, 1 exponent 5 plus 1.03 exponent 3 times 9.81 times 8. So how much will we get? 1 point, right, too big. So 3, 4, 5. 1.8 times 10 to the 5. 1.8 times 10 to the 5. Unit, it is in Pascal. Unit will be in Pascal. 1.81 should be. 1.81. Okay. Whatever lah. No other nearer one. So answer is D. And answer is D. Alright, any other question here? Right. Answer is D. Okay. Which question? 26. 26 answer is D. Let's continue. Okay. Diagram shows the apparatus to use to measure the gas pressure of the gas. All right. So this one is called YouTube manometer. YouTube manometer. Right. Measure gas pressure. What is barometer? Barometer look like this. I draw it small here. Like that. Okay. What is the use of barometer? Measure atmospheric pressure. Bottom gods to measure the pressure lah. Another barometer also measure pressure. Right. Diagram 20 shows a hot air balloon with a buoyant force 4,500, weight 3,000. So weight it is 3,000. They said one. Buoyant force 4,500. Force go up is more than down, so this thing will go up first. All right. Which one it is correct? All right. So the balloon will accelerate upward. Yes. Right. Why? Resultant force is acting upward. Yes, correct. Yeah. Why? The force going up is 4,500. Down it is weight. Right. 3,000. Right. So it will go up. The balloon will accelerate downward. No. The balloon will move upward with uniform velocity. Uniform velocity mean equilibrium. Equilibrium mean up and down will be the same. Right? So the balloon, it is in equilibrium because no, there is two forces into the opposite direction. No. Answer is A. Alright. 28. Answer it is A. 29. Diagram shows a cross-sectional of the spoiler fitted to the Formula 1 racing car. The spoiler produces downward force when the air flow through it. So what is the principle? Right? So this is Bernoulli principle. Right? Bernoulli principle said that velocity high, pressure low. Right? Velocity low, pressure high. So here, because of the A here have to travel from here to here. So velocity high, so pressure low. Right? So here fast, velocity low, pressure high. So the high pressure, it is going to press here, press it, press at the top of the spoiler, so it is more stable. Right? So I should write it here. V high, the one here. V high, T low. Right here, V low, T high. Okay, for high pressure, it is going to press the lower pressure, and Bernoulli principle, there is no calculation. Okay. Now this one, number 30, it is electricity. What is the function of this component? This is called, what is this one called? This one is called rheostat. 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 What is the function? To store the electric charge, to generate electrical energy, to limit the voltage in the circuit, to control the flow of the current. Answer is control the flow of the current. How is it work? All right, still remember or not? Electricity. Be here. I remember I gave you a here, somewhere here. Here. Okay. Now this is called rheostat. When the current flow in here, right? So this is your battery. Current flow into here, you need to use the slider. If the slider is here, it need to go very long. Long, long, then wire is long, sorry, wire long. So resistance is high. Okay, then the current come to here, finish, right? Long. Now, when you move your slider, yeah, this slider, you slide it to here. Slide to here. So the current from here flow to here, little only, right? Short only. So short mean resistance is low, okay? Current is high. So actually it control resistance. Control the length of the wire mean it control the resistance. So indirectly it control the current. Okay, so it control the flow of the current. So if there is resistance or length, also correct. So number 30, it is D. 30, it is D. Number 31, so diagram 23 shows the electrical circuit connected with 4 identical resistors R. No? Current flow to here, R1, R. Okay, what is the value of R? So this is R plus R. This is R inverse plus R inverse equal. You get, okay, calculate. I need to draw it. Okay. So this is R, this is R, this is don't know. Right? 1 over R. So this one is 1 over effective resistance. Ayo, no, I should not write. Yes, this one better. 1 over R effective is equal to 1 over R1 plus 1 over R2. 1 over R plus 1 over R. Right? 1 plus 1, it is 2. Because of the denominator, it is the same. So, it is equals to 2 over R. So, effective resistance will be R effective, it will be equals to R over 2. R over 2. Okay? So, R over 2. So, R over 2 is here. Right? So, this is R over 2. So, this is 12 volt. This is I is equals to 1 ampere. Right? So, what you need to find is if V is equals to IR. V is equals to IR. V is 12, right? 12 watt. I, it is 1. So effective resistance of this one plus this one plus this one, right? So it is R plus R plus R over 2. Okay, R 1, 2, 2.5, right? 2.5, 2.5 R. 12 is equal to 1 times 2.5. So you want to find R, so 2.5 go down. 12 divided by 2.5. 12 divided by 2.5. The answer is 4.8. Unit will be in ohm. Unit will be in ohm. So answer is C. Okay. Answer 31 is C. 31 it is C. You know how? So I repeat for one more time. This one here. This one here. These two combined, right, become 1. So you calculate, right? If you don't know, right, you calculate. So 1 over R effective is 1 over R1 plus 1 over R2. 1 over R plus 1 over R. R and R. 1 over 2 plus 1 over 2. This one and this one cannot plus. This one and this one can plus. Top can plus 2. R cannot, right? Still remain the same, right? So terbalik, it will be R over 2. So R over 2. R, and half R. So 1, 2, 2.5. 2.5 R. Right? So you substitute into V is equal to IR, you get the answer. R is 4.8. Right? You substitute it, you will get back to R is equal to 4. Is that okay? Table 1 shows the consumption information for the 4 electrical appliance 240 watts power supply. So this much, right? Which appliance use the lowest electrical energy? Right? Energy is equals to power times time. Energy is equals to PE, right? Power times time. So I lazy to calculate, right? Power times time, power times time, power times time, power times time. So we all change to same unit, right? This is change to hour. This one change to hour so that you can see, right? Change to hour. 20 divided by 60. 20 divided by 60. So it is 0.33 hour. So here it is 45 minutes. 45 divided by 60. So also 0.33 hour. Power, right? Power. So this one 3000. They want lowest, right? Lowest is okay. 3, right? Energy is power times time. Power we use kilowatt. Faster. 3 times 0.33. So 0.99. 0.99 for first one. Second one is 1.5. 1.5 times 0.33. Right? So 0.49. 0.5 only. Right? Just now 0.9 something. Now 0.4 something. Now this one is 1.2 times 2. Right? So 2.4. This one is high. Right? This one 0.5 times 1. Only 0.5. Right? 0.5 times 1. 0.5 times 1, it is 0.5. So this one is the smallest one. The answer is oven. Oven. I retest this one and this one. These two. I compare this one and this one. Power is 1.5 kilowatt. Time is 0.333. I better don't round off. I round off later salah. Right. So 1.5 times 0.333333. Okay. So 0.5. 0.5. This one also 0.5 leh. Which electrical appliance use the lowest electrical energy? Wait 45 minutes. 45 minutes I change to hour. Divide by 60. Alright. This is time already. Time. Power. Power is 1.5. Oh. See? I pressed wrong. This is not 0.3. 45 divided by 60. 7.5. 45 divided by 60. 0.75. Patutlah. Jangan salah. This one is supposed to be 0.75. Okay, so this one times this one is 0.5. So answer will be automatic washing machine. Automatic washing machine. Impossible to be two the different one. Two same one. Right? Excuse me. 32 answer is D. 32 answer is D. This is careless mistake lah. Now, what is a law used to determine the direction of the magnetic field? Right hand grip rules. And this one, if you ask me, teacher, how, why, I cannot. Right? Just right hand grip rules. Right? Diagram 25 shows the induction cooker of the ferromagnetic pot. What happens if the current in the coil of the induction cooker is changed from alternating current to direct current? Okay, what will happen to the current in the coil of the induction cooker is changed to alternating current to direct current? So if we use alternating current, so this current magnetic will change and then it will cut the magnetic flux and produce heat, produce AD current. If you change to direct current, no. Right? So no resistance, no. No change in the magnetic field and no induced current is produced. Yeah. Answer is B. Right. The pot will become hotter? No. The induced current is produced a lower rate? No. The answer is B. 34 answer is B. Okay. What does it mean by cathode ray? Cathode ray means high speed electron beam. Yeah. Okay. A flow of electron with high potential to low potential, emission of electron from the... This is thermionic emission. Emission electron from the metal surface illuminated by light. This is... We just learned it last week. This is... Seldom use that word. I forgot. Emission electron from... What is this one called again? Photoelectric. Photoelectric effect. Photoelectric effect. Write it down. You know, thermionic emission. Okay, thermionic. Okay. What happened to the voltage of the thermistor when temperature increase? When hot, right? So resistance of the thermistor is low, right? Right. Still remember how do I memorize? When hot, the thermistor normal resistance. When hot, the resistance is high, right? So this one terbalik. So resistance of thermistor is low, right? So when resistance low, voltage here low. Resistance low mean voltage here is low. Voltage here is low, right? Their resistance low, so the voltage here low. But I want here, voltage here high. Best voltage will be high. Okay, VB high. VB high. VB high, then IB high. IB high, IC high. IC high. IC high, the bulb turn on. Bulb on. So the voltage, what happened to the voltage across the thermistor when temperature increase? Right? When temperature increase, resistance low, voltage is low. Voltage here is low. Voltage decrease. Answer is right. I repeat for one more time. When hot, right, temperature increase, hot, right, resistance here low, right? Normal resistor when hot, resistance high. Thermistor terbalik. When hot, resistance low. So resistance low, they ask you what happened to the voltage across the thermistor here. What is the voltage? So resistance low, voltage is low. Voltage is low. Right, voltage is low. But if we want to continue, voltage here will be VB will be high. VB high, IB high, IC high, so the thing will on. Okay, answer is answer B 36. Answer is B. Diagram 27 shows a series of radioactive decay from nuclear uranium-238 to the nuclear uranium-226 here to here. Yeah. So based on the changes in nucleon number and proton number, that means the alpha particle and beta particle emit out through here. So if you remember the way that I taught you, this is alpha, alpha, beta, 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 alpha, alpha, right? 3 alpha, 2 beta. 3 alpha, 2 beta. Answer is B. Left alpha, right beta, beta, alpha, alpha, right? Alpha, 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 3 alpha, beta, beta. But if you want to do calculation, okay, then if this one is structural question, we do revision only. I know I can go faster, but I want to do revision with you. So 2, 3, 2, 3 add, 2, 3 add, is it become is equals to here 226 plus how many alpha? M number of alpha. Alpha is, okay, I think I should write the equation. If not, later you apa lu cakap cikgu? Okay, never mind. Here become here. Okay, so put it in uranium 238 92 238 92 become Ra 226 at the end. 226 at the end. Become how many? He, helium 42, I don't know. Electron is beta 0, -1. Okay, this is what we have. Right? This is equation A. This is the equation that we have. Okay, now we need to solve this equation. So when we solve this equation, we should solve the top one first. 238 is equal to 226 plus 4 times M. plus 0 times m, no need. Okay, so m is 238 minus 226 equal divided by 4 equal. So m is equal to 3. So m is equal to 3, finish, end of the story. Alpha is 3, no other answer. You want to do beta, you just substitute doing the bottom one will do, right? You will get the answer also, right? Okay. Okay. In the nuclear fusion process, the total mass before reactor and after is this much. Calculate the energy. So the mass defected first. Mass defect is equals to this much. 236.051 minus this 236.053. Okay. 236.051 minus 236.053. Okay, you got, oh, I pressed wrong. Should be this one first. Big minus small one. Okay, so it is 2 times 10 to the negative 3. Okay, 2 times 10 to the negative 3. 2 times 10 to the negative 3. Negative 3. Unit. So I want to change it to, this one is unit. I don't want unit. I want to change it to kg because the answer will be in joule. Right? 2 times 10 to the negative 3. Right? Time. Right? So this number, they don't give at all. So if you remember, go ahead. If you cannot remember, right, you have to go back to here. 1.66, you go to look for 1.66 times 10 to the negative 27. Yeah. So 1.66 times 10 to the negative 27. 1.66 exponent negative 7. Right? So times 1.66 exponent negative 7 and negative 27. Okay, you get 3.32 negative 30. 3.32. 3.32 exponent negative 30. The negative there, don't bother, just leave it. Don't need to bother about him. Just now I pressed wrong. Right, this negative doesn't matter. Right, it will not change my answer. So now the mass, this is mass defected already. So I want to calculate energy. E is equal to mc square. M is just now the answer here just now. 3.32 negative 30. 3.32 negative 30. And then times c square, right? 3 exponent at. E. So this answer I times 3 exponent at square. 3 exponent at square. My answer got negative. I just don't bother. Okay. Well, 2.9 at negative 13. 2.9 at negative 13. Unit it is in joule. Right? 2.9 at 2.999 negative 13 unit in joule. Right? The answer 38 answer is B. 38 answer is B. Okay. Which of the following explain the wave particle duality? The power of the photon is influenced by the number of photon frequency. No. Electron undergo the diffraction and process of momentum at the same time. Yes. This one. Light propagate in a straight line, undergoes the wave phenomena. Kinetic. No. Okay, answer is B. Right? Why? Because the electron can show both wave characteristic and the particle characteristic. Okay. Next one. Diagram 28 shows the graph of the frequency against the kinetic energy. Right? Which equation it is correct to determine the Planck constant H based on the graph? E is equals to HF. Right? E is HF. Frequency. Right? Frequency. So you want to plot frequency, right? Frequency is equals to energy divided by H. Which equation is correct? Based on the graph. Okay. This is kinetic energy. Frequency against the kinetic energy. I cannot use this one. Let me think. E is equal to. Very seldom use this formula, right? HF. HF not. HF not plus kinetic energy. Half mv squared. mv squared. Very seldom use. So you want to plot F versus this one. So this one I am going to move it to here, right? So HF is equals to E minus half mv squared. I'm thinking of, should I use this formula or not? So I want F, so divide by H, divide by H, divide by H. Okay. So F is equals to E over H. Right? Minus 1 over 2 mv squared. Okay, I rearranged it. Alright, I rearrange. F is equals to negative half mv squared plus E over H. Okay. So this one is my y. Okay, y is equals to m. M is negative, huh? M, I don't know why positive. M x plus c. Alright. Y is mx plus c. Y is mx plus c. So how to determine the Planck constant? The Planck constant is intercept E. So P is equals to E over H. So this one go up. This P P is intercept intercept is E over H E over H You want to find H. H is equals to E over P. H is equals to E over P. E is energy. My formula wrong. I guess my formula is wrong. We go back to see the formula. Aya. Here got formula leh. Why I need to go back to find? Here got leh. Yeah. Here got formula. Too much formula. Kinetic energy. This one. HF is equal to E plus, okay. HF is W plus half mv squared. Right? HF is equal to W plus, okay. Patutlah. HF is equal to W. Right? W is E lah, same lah. Half mv squared. Okay. Then I need to redo half mv squared. Right? This one divided by this one divide H. This one divide H. W divided by H. Right? So this one also have to divide by H. You see? This one divided by H. This one divided by H. So this one also have to divide it by H. I didn't divide by H. Patutlah. Okay. So F is equals to, this one is positive already. So this one, I bring it to this side. This one, I bring it to this side. No need. Wait. So I got this one already, right? I got this one already. Y is equals to Y M 1 over H. Okay, I know already. Wait. Okay. This one long. You see? What's the purpose of doing this part? So hard. Question number 40. I want to spend like 3 to 4 weeks to do this question. Right? I don't want. So frequency? Yeah, frequency. This is C. Right? W over H. Right? W over H, which is I don't have W. So this is the gradient of the graph. Right? So this is kinetic energy. Kinetic half mv squared over H. So 1 over H times kinetic energy. I repeat, 1 over 1 over 2 mv squared is your kinetic energy. This is 1 over H, which is just now I divide to get here 1. Alright, so now this is X, this is M, X plus C, right? M is 1 over H. M is equal to 1 over H. So how to get the M? How to get the M from here? Gradient of the graph, M is equals to gradient. Gradient of the graph is negative. Intercept over negative of P over Q. P over Q. Right, it's your gradient. Whereas your gradient is negative, here is 1 over H. So 1 over H is negative P over Q. 1 over H is equals to negative P over Q. Okay. So how to determine the H? So you want to find the H, the ballet. Okay, the ballet 8. So the ballet 8, H will be equals to negative Q over P. That's all. Q over P, negative Q over P. Answer is C. Susah or not? Susah. 40. You see, I also need to think so long. 40, answer is C. I do also need to think so long. This one is your admat. You learn this one, not necessarily come out. But you learn your admats, this one come out. This one you learn in MS, right? Okay. This one I don't feel like comfortable. I feel like want to rewrite it. Okay, give me 1 minute. F is y is equals to m. M is 1 over h. 1 over h. M time half mv squared. I rewrite. Okay, y is equal to mx plus c. Okay, yeah, one more time. I'll do slowly. This is from the equation, right? Just now from here, right? HF is W plus half mv squared. It is from here, right? Don't ask me where it is come from. Yeah, just now I used the wrong formula. That's why I got the negative. Okay, HF W plus half mv squared. I get it from here, right? Okay, HF is W plus half mv squared. And then because of teacher, how do you know need to divide by h? Because of your y-axis is frequency f only, so you don't want h, right? So you divided by h, divided by h, divided by h. This one gone. Divided by h here become over h. Divide by h whole thing over h, over h. So f I rewrite this one I rewrite 1 over h I write at the side here half mv squared because of it is kinetic energy. Plus this one y now y okay y correct y frequency m x plus c okay. Now the c is w over h. Just now my point is w over h is my intercept, but I don't have answer, cannot do anything, so I have to get it from the gradient. The gradient is 1 over h. Is the gradient. Gradient is negative p over q. Don't ask me why negative. Ask your MS teacher. That is not my job. Okay. Okay, I think that's all for today. So I want to shout out to this Telegram channel, exercise student, right, for sharing the notes for us so that we can do the question. So thank you very much for this. If you want, you can go to find the Telegram to find this channel to get the notes, but I will send you already lah, so you can use it anyhow. So Thursday we are going to discuss the paper 2 Kedah one. So after that we are going to one by one discuss. All right, so I'm going to stop here. Have a nice day. I'll see you. Bye bye. I'm going to stop here. Bye bye.